Welcome to lesson 8.5, shifting, shrinking, stretching, absolute value functions. So I want you to take a moment to pause this video and work on the bell ringer if you haven't done so already. So go ahead and do that now. All right, welcome back. Let's take a look at what you got for your bell ringer. So the first one, if it's shifting 3 units to the right, well, remember the right or the left is when the absolute value has the constant inside. So we can eliminate 3 and 4. And when we shift to the right, we are subtracting 3. Okay, number 2, here find f of negative 10. All you had to do was take your f of x and plug in negative 10 for x. So you have the absolute value of 3 times negative 10 minus 4 plus 2. Well, that's the absolute value of negative 30 minus 4 plus 2. That's negative 34 when we add those. Plus 2. Absolute value of negative 34 is 34 plus 2 gives me 36. All right, and the last one. What is the possible range for all absolute value functions? Remember, positive real numbers and 0. All right, so our objective for today is to transform absolute value functions. So when we flip our page, so what I would like you to do, please, on this next page, that looks like this one right here, same color and everything. I want you to use the rules that we've learned, and I want you to tell me what's happening to this absolute value function when I rewrite them in many, many different ways, in many, many different functions, okay? So I want you to take a moment to pause the video. Please try to do this on your own, okay? Pause the video, write each of these, and then hit resume when you're ready. Ready, go. All right, welcome back. Let's take a look. I'm just going to leave this here for you to see if it matches mine. So I'm not going to go through it for you, but you can go ahead and make sure that they compare. All right, if you have any questions on any specific ones, make sure to circle them and we'll talk about them on Monday. All right. All right, so now let's flip the page. Now we have an exploratory challenge. So what I want you to do first is graph the absolute value function. Then we want to graph g of x, which is f of x evaluated when x is 2x. So what that really looks like is g of x equals the absolute value of 2x. Okay. Same thing with this next one. H of x is saying that we want to evaluate the absolute value at positive 1/2 x. Okay, so I want you to graph these 3 functions, see how they compare, and then we'll talk about how they stretch or shrink. So go ahead and pause the video and do that for me, please. Welcome back. If you take a look, we'll see here that our very first function, f of x, looks like this. Then we have our g of x, and it looks like g of x made it a little bit narrower, and it was narrower by, in fact, 2 times smaller for our x, or for our 2 times larger for our y values, right? Each of our y values got 2 times bigger, which means that the v is going to kind of like shrink in and make it narrower by a scale factor of 2. Okay, same thing with 1/2, only this time it didn't shrink, it got wider, and that's because all of the y values got smaller by half of their original value. Okay, so you should have g of x narrowed and h of x got wider. So what does that look like down here? Well, it narrows k units if it's within the absolute value, and k is not a fraction. And here, it widens if k is a fraction. Okay? All right, let's flip the page. Another exploratory challenge. So for this challenge, I want you to do the same thing. I want you to plot f of x. Now here, g of x is f of negative 2x. So this is g of x is equal to, well, f was the absolute value function, so it's the absolute value of negative 2x. So that's what you're going to plot for g of x. Same thing here for h of x. We're evaluating it at negative 1/2 x, so it's the absolute value of negative 1/2 x. Okay, plot these 3. Let's compare them and see what happens when they stretch or shrink. All right, welcome back. Let's take a look at what we had here. So my g of x looks like it got narrow. my h of x looks like it widened out again. Now, although these are both negatives, because they're inside the absolute values, my answers, or my y, when I evaluate, are always going to be positive, which is why it was not reflected over the x-axis, because the negative was inside those absolute values, which make them positive in the end, right? So in the end, we have that if y is equal to the absolute value of negative k times x, then we shrink k units, right? We get narrow by k units. And when y is equal to the absolute value of negative 1 over k to the x, we have that it shrinks k unit, stretches k units, Miss Wall, stretches k units and widens, okay? All right, so now I'm going to flip the page. Let's take a look here. We have a chart describing transformations. I wish I was here to do this with you in person, but alas, I am not. So these are all of the different types of ways that we can write an absolute value function from a transformation, right? And there are quite a few of them. I want you to see if you can pause the video and try to explain what the rule is for each. Okay, when you're ready, please resume and check your explanations with mine. So go ahead, pause the video. All right, welcome back. Let's see what happens. Now, I know what's going to happen. I'm going to start explaining these, and it's going to get all mumble-jumbled, and I'm going to say plus instead of minus on accident, and Miss Wall is just going to be a goof because there's so much k's and so many x's here, right? So instead, I'm going to have you just read these and compare them with yours, and if you have any questions on any of them, please circle it, and we can talk about them on Monday when you see me, okay? So go ahead and take a look at these, see how they compare. Pause the video if you need to. All right, did you pause it? I hope you did. Okay, so now that was it. You are complete. You have homework to do. Yay, homework. I did not just show you those answers. That would be silly of me. All right, it's been a very long day. So I will see you later. Bye.